Hello everyone, myself Paul Makwana, Assistant Professor of EC Department at LJ Institute of Engineering Technology. Welcome to the session of Satellite Communication. So from chapter number 6, that is a space segment, we have seen how the stabilization of attitude will be done. So there are different two types of stabilization. Can be momentum stabilization and spinning stabilization. So why this attitude control is required? That we will see in today's session. What we mean by thermal control and what is telemetry tracking and the command system. So over here, the requirement of attitude control system is first the requirement of the change in the orientation of satellite and the change in its orbit will be controlled by during the launch phase and the operational phase of the satellite. So the orbital control is required to control the orientation of the orbit. That means, as my satellite is moving orbiting around the Earth, it must follow the same orbit as it complete the one rotation of the Earth. Okay? So we need to correct the effect of perturbation forces. Right? So during the launch phase, the control system will maintain its correct attitude of the satellite, and we are able to maintain its link with the ground earth station. That means it must follow the same orbit to provide the different images from the Earth and to get the data from the Earth station. Okay? So we need to control its orientation in such a way that my satellite is in the desired direction, the correct direction for the magneto. Right? So when the satellite is in the orbit, the attitude control system will maintain its antenna orientation. That means it should focus in the desired direction at which my ground station antennas are oriented. Okay? So there will be an accurate orientation of my satellite antenna. Right? This precision with which my attitude control needs to be controlled depends on what is the beamwidth of the satellite. Right? If it is having a narrow beamwidth, that means the high accuracy of the attitude control system will be required. The spot beams and the shape beams are required for a more precise attitude compared to earth coverage or the regional coverage networks. Right? This is the requirement of attitude control system. Alright? So over here we have seen the different types of attitude control system, like active, passive. Second thing, what is satellite anatomy? Right? Now third thing, why the thermal control is required. So first, there are basically three reasons. The thermal control is required for the sun's radiation. Second, there is a thermal radiation from the Earth. And third, because of the equipments inside the satellite. Okay? For these three reasons, we require a thermal control. Right? What we can use? We can use a thermal blankets and the sheets to provide the insulations. And we can use the radiation meters to remove the heat from the communication field. Alright? These are the ways that we can control the temperature of the satellite. Now the next topic is telemetry tracking and the command system. Now what is the function of telemetry tracking and command? So it supports the function of the spacecraft management, which are vital for success operation of all the satellites. Okay? They can be treated from different separately from the communication management. Alright? So the function of telemetry tracking and command system is first, it will monitor the performance of all the satellites of system, and it will transmit the monitored data to the satellite control center. Second, it will support determination of orbital parameters. Third, it will provide the source to the Earth station for the tracking. Okay? And then lastly, it will receive the command to correct its position, alright, for performing a various function of the satellite. Right? Now we will see all the systems one by one: telemetry, tracking, command, and the monitoring. Right? So first of all, what is the function of telemetry from subsystem? It refers to the overall system, overall operation of generating an electrical signal which is proportional to the quantity being measured. So data will include the latitude information and the environmental information. The environmental information means what? It will include the magnetic field intensity, what is the direction of magnetic field, and what is the frequency of that. Okay? Third, the spacecraft information. That means what is the temperature, what is the power supply voltage, and what is the stored fuel, which is pressure, and what is the pressure of it. Alright? So these three are the data that we can, or the telemetry subsystem will provide. Alright? See, over here, the telemetry, tracking, and the command monitoring system, which over here, this is the block diagram of telemetry system. You can see over here, the first block is the sensor, A2D converter, operator, modulator, and the telemetry transmitter. Whatever the output of the sensor that can sense, okay, is given to the A2D converter. And the data that we are going to apply, it should be in the form of digital. Okay, that is going to come into the formatter. And my sensor's data is in the form of analog. The analog data is converted into digital with the A2D converter. That signal is going to be modulated by modulator, and this telemetry signal is applied or transmitted through this transmitting antenna. Alright? So the telemetry data rates are in the range of 150 to 100 bits per second. Right? So this telemetry signals is commonly used by the ground station for tracking of the satellite. We can also use a distributed telemetry system that are increasingly used nowadays. Now, what are the functions of the different blocks? See, the digital encoders are logged in each subsystem for the satellite, and data from each encoders are located in each subsystem. So they are going to be sent to central encoder via a common time shared bus. Why? Because it reduces the number of wire connections and it also permits the expansion of initial design and the facilities that we are going to use in the satellite. Alright? Now second we are going to study what we mean by command subsystem. So it will receive the command which is transmitted from the earth station. It will verify the reception and it will execute these commands. What are the commands? The commands are like, do we require to switch the transponder? The antenna pointing is required or not? Do we need to direct or speed up the solar array? What is the battery conditioning? Whether the thruster is fired or not? And whether we need to turn on the turn off the heaters or various subsystem. Alright? So these are the commands that is required. So this is the block diagram of the command subsystem. The command is going to be received from the earth station which is located on the ground by the receiving antenna, going to be applied to the command receiver. That signal is decoded by the command encoder and it is going to be verified and that command is going to be executed. Right? So the verification on which date verification will be done and it is going to be applied to the telemetry transmitter. Right? So the demand verification of each command by the satellite will control the sender before the execution. So to reduce the effect of hybrid error, coding and the reputation of data are improved. So by combining the output of two receive chains, we can get the bit rates around the 100 bits per second. Alright? Now the next is tracking subsystem. So it provides the angular and the range tracking. That means how far the satellite is there. What is its angular position? Okay? Angular tracking can be done by one-of-us tracking and the range will be tracked by a round-trip time window of the signal. After how much amount of time I will get the signal to receive the signal from the satellite. Okay? So it is done by the time delay which is obtained by measuring the phase difference between the transmitted signal and the received signal. And the transmission of this TT&C, that is pseudo-random sequence, is also be done. Alright? So this is the overall diagram of telemetry, tracking, command and monitoring. See, the first structure, cylindrical structure, is a satellite. We can get the ranging information at the telemetry station, and this ranging data is going to be applied to the range, command and telemetry block. We can say that the telemetry, tracking and command station. Okay, that will provide the voice and the data links to the data communication and the reduction facility. The data can be analyzed and it is going to be applied at the separate control station, and the data is going to be stored in the computer and it is also applied into the computer center. Okay, for continuous tracking and the monitoring. So these are the TeleSec headquarters which are located, and We can get the voice and data links and we can provide it to the telemetry tracking and command station. Okay? And that can transmit the data to the satellite to orient its correct position. Alright? So over here we have done what is the requirement of attitude control system, what is telemetry tracking and command system. Alright? But still, if you have any doubt, you can ask me anytime on my video email ID. That are the references that I have taken. Till then, thank you for your attention.